Bucket sort avoids comparing every pair. Drop each element into a bucket by its value range, sort inside each bucket, then read the buckets in order from left to right. Use bucket sort when you can map each key into a fixed number of range bins, and values are spread across those bins, not piled into one. Floats in 0 to 1, or integers with a known min and max, are typical. Skip it when almost everything lands in a single bucket, the range is enormous, or you need a general comparison sort. Bucket index is value divided by 10. 29 goes to bucket 2, 3 goes to bucket 0. Scan the input left to right and drop each value into its bin. Scatter done. The 10 to 19 bin stays empty, no input value falls in that range. Each bucket is sorted on its own. Insertion sort is the usual choice, the lists are short, it runs in place, and you already know the moves, we just apply it locally, bucket by bucket. Bucket 2, 29, 25, 21 becomes 21, 25, 29. Every non-empty bucket is in order. Bucket 1 stays empty, ready to gather left to right. Gather, walk buckets left to right and append each value in order into the output. Skip empty bucket 1. 3 and 9 from bucket 0, then 21, 25, 29 from bucket 2. 37, then 43 and 49. Output complete, fully sorted. Map to bucket is the main design choice. Smaller keys must land in lower bucket IDs, gather only concatenates buckets, it does not repair global order. No min and max, pick k bins, and split the range into equal width buckets. Our integers use bucket equals min of value divided by 10 and the last bin index. Floats in 0 to 1 often use floor of value times k. Avoid sending every item to one bucket, using enormous k on sparse keys, or any mapping that breaks sorted order across bins. Let n be the array length and k the number of buckets. Scatter and gather are order n. When keys spread across bins, each in-bucket list stays short, average time is order n plus k, worst case, everything in one bucket, and in-bucket insertion sort becomes order n squared. Space is order n plus k for the buckets and output. Define bucket sort with the array, bucket count k, and a mapping function. Allocate k empty bucket lists. Scatter, loop over every input value. Map the value to a bucket index. Append the value into that bucket. Sort phase, visit each bucket list. Run insertion sort inside the bucket. Start an empty output list for gather. Walk buckets from 0 to k-1. Walk each value still in the current bucket. Append it to the output in order. Return the sorted output.